Okay, so after a previous lecture, we are going to model this file cap under lift code, and then we'll go for analysis and design. So if you're new here, I will request you please watch our previous lecture. Okay, so now I'll go for drawing of this model. Now I will use a software CSI SAFE, the latest version 22.5. okay, and here I will start modeling. So first of all, when we're here, we'll go for our first step. So what will be the first step? We'll define our grid system for everything, and here you will see your previous work. Now I'll go for new model, as we are starting a new model. Then I'll use building in setting with, okay, and here I'll use US customary region United States, and still section database. It's not required because we are going for concrete design. You only need this up. So concrete design code. From here you can select any of that code. So I am going to use this code. Then click OK. Now here I need 2 grid in X direction and 2 grid in Y direction. So what will be the spacing between the two grid? The spacing will be 11 feet and maybe, so what is the distance between one side and another? 11 feet and 8 inch. 11 feet and 8 inch. So what will be the value of 8 inch? 8 divided by 12. 6667. 11.66. 11.6667 in both direction, X and Y. Done. Now actually this is not essential for us, so a story above, okay, it's not required for us. So I'll go for grid only, then click OK. Done. So if you see here, 11.666 feet, and here also 11.666 feet. That means 11 feet and 8 inch. Now we'll start drawing everything here. Before that, I'll go ahead drawing. I'll go snap option. I'll use this option, int and midpoint, line frame, feeds, then fine grid. Okay. Then click apply and okay. Now if you come here and if you want to draw something, let's say if you want to draw a line, you will get everything, midpoint here, like that. Now I'll go for drawing our point. Okay, so before drawing our point, we can go for something like we can go for define our materials property. So here our a given materials property is given here for 1000 psi or 4 ksi. So I will change it. I'll take it 3500 psi concrete. It's 150. It's okay. And modulus of elasticity, we have to change this option, but before that I will change the value here 35, and it will also be 35. Then click OK, and here we need to change the modulus of elasticity. So to change modulus of elasticity, I'll just go to Excel sheet, and here you'll see option here EC and ES, and just okay, already provided here. So this is the value in PSI and KSI. First of all, I have to check here that which value we required. Actually, we required this value in LB per inch square, that means PSI. I'll come to Excel sheet, and from here PSI I'll copy and paste this value here. But from here, for your case, you have to select which types of aggregate you are going to use, brick or stone. So I'm going to use stone. Done. Then just simply copy this data from here, copy, and paste it here. Okay, done. Now I'll click OK. See, it changed. Now I will go for our steel. Okay, now we have to change our steel. So here a 60 grade steel is given. Here 50 grade steel is given, grade 60. I'll come here and I'll change it from here. So our unit weight per volume will be same, the modulus of elasticity will be same, because in steel this value will not change. Okay, and I'll just come here. Only I need to change this value. I need to change this value. So how will change this value? To change this value, we have to understand something, that here you can see the design property of rebar materials. It's given minimum yield strength Fi. That means this represents the grade of steel. So in our case, I am going to use the steel of 500, grade of 500. Okay, so if I go here, add new materials property, if I go here for a unit tested, okay, and then if I go for rebar, and here you will see two options, ASTM 615, and here you will see this 3 option. I will use this option, grade 75. So what is the grade 75 actually? Grade 75 is more than our requirement, but grade 75 actually for your case you will select as per your requirement, you will select it. But for my case, I have to modify it actually, because in our country we use 500 megapascal concrete strength. Okay, so if I convert it, it will be 7250. But here the grade is available for, so sorry, I'll select 75, and our grade is available for 75. That means 75 KSI, but we need 72.5 KSI. I'll click here OK, and I'll just provide here 72.5 KSI. Okay, it will be Fi, and if everything will be same, just I'll come here and you'll see here is the default value. Okay, here is the default value. Now I will change just this value, 72 and 5. Okay, and the rest value will remain same. I'll not change anything. I'll just change only this value. Actually, what is this value? The maximum tensile strength. This is the yield strength actually, where at point where the yielding will start. But the maximum tensile strength, that how much tensile strength this rebar can take, actually we'll get this value, we'll get this actual value after completing our lab test. But as we are not going to perform any lab test, so what we have to do, I have to take this assumed value here, and here the expected yield strength. So this is the minimum yield strength, minimum. That means less than this value can be happen, but in the expected, so what will be the expected value? Yes, the expected value. Then expected tensile strength. So what will be the expected tensile strength ultimate? So actually I'm not going to discuss about that, or not going to change anything from here right now. So what will I'll click OK. I'll just focus here, and this is the main value actually. Okay, and nothing to worry about those value. Just remember that for which grade you are using, this value should be more than this value. That's it. Then click here OK, and click OK. So done. Our materials property definition OK. Then click for section properties. Now we have to define our section properties. I'll delete this first one. For this one I will modify, let's say PC pile cap. So our pile cap will be let's say 35 first time, as this is the biggest structure, so 3510. And slab materials, this is the slab materials model shell thin, it's okay. Then modifier, if you need to provide any modifier, I'll not use any modifier. Then here's types, it will be matte. Okay, for matte, and for pile cap we have to use matte, and thickness will be 35. Done. Then I'll click Okay, add copy of property, then our file 35. Actually, what is the 35? 35 is the thickness of a total section. So 35, it will be also made 35, and it is 35. Okay, done. Then file, and then we need another thing, that is our column. Okay, value of our column. So as we're not using column here, we're using here wall. So to analyze this model, no need to assign to analysis, actually to analyze the mat foundation, pile cap, we will not use any wall here, just will provide load from the wall. Then click okay. Now I'll come here, we are absolutely done. Now I'll come here, I'll go for our river, and here you can see our river is given as a bar number. Okay, I will clear it and I will add SI. Okay, so I just need 20 mm bar, then I need 16 mm bar to design it. Only these two bar is available. It's okay for me. Okay, because in our country we had 18 mm, 10 mm, 12 mm, 16 mm, 20 mm, 25 mm, then 32 mm, 50 mm, like that. Okay, so for my case I need 20 or 60. For this reason I need this bar ID. Then click OK. Done. We're absolutely done. Now we'll go for our load pattern. So what will be the load pattern? Already two load pattern is given, dead load plus live load. So dead load will multiply its self weight value with 1, and the live load will be 0 0, and done. So I'll click OK, and I'll go for load case. Also this is dead load and live load, it's done. Okay, and again I'll go ahead define, I'll go for load combination. So here I can add default load combination for concrete slab or beam and composite beam. Okay, and click here. Okay, you'll see we have found two compound point for dead load, and here another compound point to dead load plus 1.6 live load. This is for design actually. Now for analysis I need another combo. So I'll click add for service condition actually. Service condition and 1. Okay, condition 1. What will be this value? 100% I mean 1 times of dead load plus 1 times of live load. Okay, 100% of dead load plus 100% of live load. Then click OK. Done, and click OK. It's okay. Now we are ready for our next analysis. So next step, so what will be the next step? We'll draw our structure. So to draw a structure, I will use this option first, draw a rectangular floor, and from here I'll select our PC, that means pile cap. Okay, and I'll start from this point to this point. Done. We have completed our pile cap, and if you need to, or if you want to see it in 3D, just simply click here, add new windows. You'll see it here. Okay, and if you extrude it, you'll see here is our pile cap. Now I will draw our pile. So to draw pile, we need some specific point, and by using draw joint object, I'll draw some point. So first of all, we need a point here where this point will be, our center point will be available. I'll come here, and so linear from this point to this point, distance will be 20 inch, and this point to this point will be 20 inch. So in from this point and this point will be 20 feet in x direction, 20 inch in x direction plus 20 inch in y direction. I'll come here, 20 in y, also 20. Then click here, you'll see a point here. Again I'll click here for minus, and if I click here, I'll get point here. If we click minus x, and if I click here, you'll see a point here. If we click plus 20, I think you will understand it. Done. At this point is okay. Now I'll close it. For plus 20 at midpoint, if I come here at midpoint of this model, okay, and if I click here, I will get this point here also. So in minus direction, I'll click here and I'll get a point here also, and here I need another point. So in y direction, in y20, if I click here, I'll get a point here, and for minus 20, if I click here middle, I'll point here, and I need a point at midpoint. See, here is the midpoint. Okay, I'll make it 0 0, and where is the midpoint? Actually, here is the midpoint. That's it. Okay, but for your case, if you did not able to, if you're not able to find out this midpoint, just simply take a reference, and from that point, what is the value in x direction, what is the value in y direction, then you will find out this point actually in the same way. Now we'll go for pile cap. I'll use this option, draw pile around a point, then I'll go for pile, and what is our pile? It will be circular, and dia of our pile will be 20 inch. We click here, very carefully click on every joint. Done. If we go to extrude view, see, seeing our pile is here. Okay, done. Now we'll go for our next step. So what will be 3D? So what will be the next step? We'll provide a spring property below pile. So I will provide a spring property. So to provide a spring property, I need to go to Excel sheet, and here the pile spring constant. Here, this is the equation actually of, okay, I will just provide a diameter of our pile. So what will be the diameter? 20, length of our pile 90 feet, then S10 3500, and pile capacity here. Okay, so this is the value of our spring constant, and now in which unit is this value is required? This I'll go here, define, then spring property, then point spring at okay, p spring 1, it's okay. Then our value will be in keep and keep inch actually. Okay, so here compression only, then compression only, then we'll go for value in keep per inch. I'll come to our Excel sheet, I'll get it value in keep per inch. If you need in another unit, just change this unit as per your requirement, paste it here, copy this value, done. Okay, and click done. Okay, now I will assign it. So to assign it, I will click here to select all of our joint very carefully, not pile, sorry, see here a pile have been selected, just simply click to deselect. Done. See, 9 joint selected. So this is the point Now I'll come here, assign. Okay, then joint, then spring one, click apply and close. So if you come here, you'll see at every point a spring is available. If we go to 3D, you'll see it here. Okay, you'll see here spring. Now we are done with our spring. Now we'll go for next step. So I'll go to plan view, and this is the most important step, that we'll assign our load here. So how will assign our load? First of all, we have to find out the center point of our wall. Okay, center point of our wall. So I will go to our AutoCAD, and here we need to find out the center point of our wall. So here our wall at here is our file cap, and I'll put it here. I'll copy it, Control C. I'll copy in that point. I'll click here. So what we have to do, I have to move it in that side little bit, and for top it's okay for top side, because in that side we need this distance, and in that side, if I come here from that point to that point, sorry, here we have almost 11 more than 11 inch. It's done. Now here I have 2 feet and 4 inch, 2 feet and 4 inch. So I will move this file cap little bit in that side. So to do it, let's say I will consider for 2 feet. What is the value actually here? 2 feet and 4 inch. So I'll move this 1 feet 1 inch. Okay, click move, click here reference point, and in that side must open this option, ortho mode. Then in that side total 13 inch, enter, done. I will delete this one, I'll delete this one. Okay, now I'll copy it. Okay, I'll copy it. And take it here. Joint it. Okay. Let's see, Control V. So here is the position of our lift core over the pile cap. Okay, now what we'll do, I'll go for our next step. So what will be the next step? I will find out the middle point of this lift core. Okay, middle point of this lift core, and we'll go for load assigning. Now how will do it actually? To assign this load, I will find out the middle point. So to find out middle point, I will click here, and I'll click explode. Okay, now to find out middle point, I will use this option. Well, let's say polyline, and from this point and respect to this point, I'll start from here. Then click ortho mode, and also click here on this midpoint and come here. Okay, for this side I will just take a line here and take its middle point. Very carefully move it from here. I'll take its middle, it's done, and I'll come here. I'll extend here a little bit, explode. Yeah, I'll close it. Okay, now I can, okay, let's state here. Now here I have to provide load. Okay, now to provide this load here, I will just draw this line. Okay, so to draw this line, I'll take some point. First of all, I need a point here, I need a point here, so I will take this point first. So from this point to this center, 2 feet and 6 inch, and from this point to here it's 11.8 inch. Okay, and it's 2 feet 6 inch, that means 2.5. so I'll take this first, this point first. I'll come here, I'll save this model. So in project and for 9 file, for 9 file, save, and again I'll go here and I will take this model as a default format for further work. So for that I'll come here, file, save as, and let's say AD analysis design, click save. So now we are working on this file, and if I go here, you'll see they have another file which will use as backup file. Close. Now I'll go here, draw joint object. In X direction it will be 2.5, sorry 2.5, that means 24 plus 6, 30, and in Y direction 11.8 inch. Again I'll go here to take it 11 feet and 8 inch and 2 feet at 6 inch. Okay, then click here. Okay, so it will be in X direction and minus Y direction. That is the point, first point. Now we'll go for point here. So this distance will be same in X direction 2.5, but we have to find out the value in Y direction. Two feet and 11 inch, that means 35 inch. It's here. Okay, now I will go for let's say I'll go for this point. So to find out this point, its Y direction value is same. Now I'll go for X direction value. For X direction value minus X direction, from this point to this point, it's 2 feet and 4 inch. That means 24 plus 4, 28. 24 plus 4, 28, minus 28. Here. Now I'll take a point available here. This value will be same. Now we'll go for y direction value. (10" here. Now in that set done, I'll go for a available point. We'll go for our next point here. So okay, actually we have to take a point also here. So where is the point? I didn't take it. That point I have to take also. This point is 2 feet 6 inches, that means 30. And what will be the value of this point? It's 1 feet and 11 inch. That means 23. 12 plus 11, 23. 30 and 23. Minus 23. Click here. Here or that point. Now the value in y will be 23. So what will be the value of the value of y will be 23, and so now value of x will be for this point. Click here. Value of x will be 2 feet and 4 inch. So what will be the value of 2 feet and 4 inch? That means 24, 28. Yes, 28. Minus 28. Minus 20. Sorry. Minus 28. Here. So from that point to that point. And that point to that point. It's okay. Now we'll go for our line. I'll close it. I'll click here, draw beam or something, and from frame it will be frame, and our property, that will be none. So where is the none? Actually here's the none. Okay, and let's take it as usual. Click here to here, then here to here. Enter. Again click this point to this point, and this point to this point. Done. If you see here, done. And if you click here, and if you click here, you'll see only this member are being selected. 4 member. Okay, now we'll assign our load. So how we'll assign load here? To assign load here, we have to we have to assign this load as a distributed load, because our lift code will provide its load over the pile cap as a distributed load below its wall. Now one thing you have to understand, they have 1 point and they have 1 point. Okay, so in wall, actually we have I will open our load. So in wall we have found load in 4 point. Okay, in 4 point we have found it. We have found this load on 4 point. So why 4 point? Because when they have created this model, maybe they didn't take this extension part to draw model. This extension part also, this extension part, they didn't take it, but we have to take it. We have to take it as it's available on our project. So how we'll do it? We'll do it very simply. First of all, I will take this load and I'll divide it, that load, for half of this load will be here and half of this load will be here. Okay, so I'll go to here. I'll open our this line, and to find out this I can use an Excel sheet. Okay, let's say I will take this point as a point 1, 2, 3, and 4. Okay, in this way 1, 2, take it this point as 1, 1. Okay, and it will be 2 for our easy calculation. It will be 2, it will be 3, and it will be 4. Done. Now at 1 I will place this load here. 1, 2, 3, and 4. So what will be the load? We'll come here, we'll open this image. Our load will be 260.08 at 292.01, then in 345.45, and here 307.69. okay, now actually for this member it will get half of this load and half of this load. Okay, let's say this member name will be AB. We have 4 members, so this member name will be 1, 2. Then this member name will be 2, 3. Then this member name will be 3, 4, 3, 4, and this one will be 4 on. Okay, I'll click OK, and this member will get load from 1 and 2, half of load from 1 and 2. So I will here half of 1 and 2, so equal to, like, let's take a bracket, half of 1 in this way plus 1 plus 2 divided by 2, sorry, divided by 2. Okay, now go for 2, 3. It will get load from 2 and 3. If I click here, you will see the value from 2 and 3, and if I copy it, it will get value from 3 and 4, and I'll click here and it will get value from 4 and 1, so it will be 1. That's it. 4 and 1, half of 4 and 1. So done. We are getting all load, and if you check it that all load is okay or not, click here, sum, click here, just copy it, paste it here. You'll see for that load and that load, they're the same. Okay, now I'll distribute that load. That load. How? I'll give the length of this wall here. So what is the length of all 1 and 2? I will come here, take a linear from this point to this point, and its value is 6 feet and 10 inch. 6 feet and 10 inch. That means 6.833. 6.833 feet. Okay, then what will be the length of 2, 3? So I'll come here, this is our 2 and 3. I will take this length from this point to this point, 8 feet and 11 inch. So what is the value of 11 divided by 12? 9 on 6. It's 8 feet and 11 inch. 9 and 6. Then for 3-2 member, sorry, it's not 3-2, it's 3-4. For 3-4 member, come here and has the 3-4 member. So 3-4 member and 1-2 member are same. Same. And here for 4 on, here, and I'll go linear from this point to this point. It's 7 feet and 9 inch. That means 7.75. 75 feet. Okay, now we'll go for linear load. So how we'll go for linear load? I'll click here. I'll divide this load with this distance. This value will be keep per feet. That's it. We need the we just need this load right now. Okay. Sorry. So for every point, for every wall, we have found our value in keep feet. Now we are ready to analyze this or assign this load. Okay, so how will I assign this load now? I will just go to here. Now for this wall, I will select this wall. See, one frame selected. I'll go assign, then frame load, distributed load, and actually they have issue now. My client have provided me this load as a dead load, live load, and rough live load. Okay, so I will divide that load as a dead load and live load as per my experience. But for your case, you will get this load as a dead load separately and live load separately. Okay, then calculate this for live load first and then dead load then dead load. Okay, so I'll take 80% of load will be dead load and 20% of load will be live load. I'll consider it. So it can be more or less, but it will not affect our design anymore. So let's say it will be dead load, live load. Okay. .8. 0.2. That's it. Okay, I will come here. Okay, now we'll provide this load. This is the final load as a live load and dead load. Again, I'm telling you, for your case, you will just use the actual load. As I have no dead load and live load separately, that's why I have divided it as per my experience. But I think that live load will be less than that load also. Okay, so what I can do, I can take it as 85%, and I can take it as a, okay, take it like that. Now I'll go to software. Our first dead load for member 1 to it's 32.32. This member is selected and our value will be 32.32 keep per feet. For your case, if this unit is different, you can change it. Then for dead load, click and take replace existing load. Force, gravity, direction will be gravity, and click apply. Done. Okay, you can see this is available here, but for graphical issue it's not showing. Then again I'll click here to select this frame, then I'll go assign frame load, distributed load. I will now assign as a live load, and this value will be, what will be the value of live load? 8.08. 8.08. Then click apply. Now it's 8.08 now. And if you click here, and if I go here, checking force, there are option to see the load actually. To constant, a uniform, maybe uniform load set. Then click apply. Load. Other check. Okay, no need, just close it. Click here, frame load assigned, dead load, click apply. So here is the frame load, you can see. Now I'll go for, let's say this, okay, this member 2 3. Okay, after 1 2, I'll click here for 2 3. I'll go for dead load. And what will be the value of dead load? It's 28.6. 28.6. Everything is okay, simply click apply. 26.8. Now go for live load. And what will be the value of live load? Our value of live load will be 7.15. 7.15. 7.15. Okay, then click apply. Okay, sorry, we have to select that member first, then click apply. Done. Now I'll go for this member. So what will be the value of this member? It's 38.23. 38.23. 38.23. It's dead load for this member 3 4. Done. Again select this member to assign live load. 9.56. Here as a live load 9.56. Now we'll go for last on 4 on dead load. It's 29.3. Dead load, apply. Again select, live load. It's 7.33. Click apply and okay. So actually we have done everything. Click apply. We have done everything. See here our dead load. Then if we go for live load, here is our live load. No, it's not showing here. To see it, go here option, then graphics preferences, font. Okay, so I'll provide this font size as a 12 and the minimum will be, let's say 8. Okay, minimum will be 5. Click OK. It's 7.5. It's now it's showing little bit. And also if you want to increase the size, this text is high, also go here. Okay, $15 points, it will be 8. Okay, 8.5, 7.5, 7.3, 3. And for dead load, click apply. That is a dead load. So now we're all set and we are completely ready to analyze our model. Now they have some work like select here for meshing. click shell, and they have float auto mesh option, but I will use only this default option because when we have a complex situation, here is we have a complex situation, so for this types of situation we can go for default actually. Okay, I'll click apply, and everywhere our value is default. Now when we have applied it every value as a default, now we'll go for analysis. Okay, I will go here, run analysis, and see what happened. Check warning, we have warning. So actually we have no error, we have warning, so I'll click OK. And see what happened. Okay. Okay, actually in our model we're seeing that the excessive or excess displacement we are seeing, so we have to check it why we are seeing that. But actually we have to take this model for our as it's giving us a huge displacement, but if you take your mouse here on that point, you will see a lower displacement is available. So displacement is showing on our file actually. So what is the reason of that? Maybe this happening because of improper meshing. Okay, so what we'll do, you can see here and here it's rotate actually, and also they have a element like, see here it's rotating like that, here it's rotate in ux, and here in minus direction. Okay, so what we'll do to solve it, I will close. Okay, before that I'll go here, display punching design, and we're seeing that this member all member are okay in punching, and I'll go to our plan view for this member. I'll go here, I'll go here, load case, service condition 1, sorry, here for displacement. Okay, and now I'll check here that what is the displacement offer. Footing, it's 0.16, 0. It's also less, it's also very less. 2, 3. Okay, so now what we'll do, actually our main mat are not displacing, but because of that irregular meshing, you can see here, because of irregular meshing, it's here, because of irregular meshing, here we are getting this issue actually. So I'll close it, I will check again, go for this solution. Now what we'll do, I'll go for select, then properties, slab section, select both materials or section, and click select. You will see 11 shells selected. Then I'll go here, ascend and shell, then floor auto mesh option, and from here I'll select this option, auto cookie cut. It's very important actually. This is very important because how your total element will be divided and how you'll transfer load from one point to another point, it's very important. Okay, so we have to do it perfectly. They have if we go for auto cookie cut, object into a structural element, mesh at beam and object meshing line applied it to horizontal floor only. Then a mesh at vertical or inclined wall it's applied it to horizontal floor only. Then mesh at visible grid, if they have, as we have no visible grid here, so this option will not be applicable. And add restraint on its if corner have restraint. Okay, so if they have any corner restraint, that means if they are corner resistant, then we used to do it. But in this time, no need to add it. Just simply click apply, close, and again go for run analysis. Okay, actually why this is showing, I'll go to here. Okay, so here is the WRN warning. Right click, sorry, double click, then select notepad once, and it is giving us a warning. Check meshing at area 2, 3, 4, 5, 6, 7, area 10, a 50% increment. Okay, I will close it. I'll come here. So actually there have several areas, it's have been divided, you will see. Okay, and we'll go for further analysis, no problem. Now if I come here, now we can see this excess displacement that are not showing right now. So what are the issue? Previously our that meshing was not proper. Okay, so as that meshing was not proper, that's why it's given us a huge issue there. Now I will again go for displacement combined section 1, then click apply. Okay, this is for overall load, and our maximum displacement is 0.16 inch. Okay, so it's save. Now I'll go for another thing. So I'll check our load on pile. Okay, before that I will go for check. I'll click here support restraint, then combo for service combo, I mean for all dead load and live load, then point reaction arrow FZ, click apply. Here we are seeing that our pile capacity, we're seeing the pile capacity here, I mean load on pile actually. So this load on pile is here 156, and if we go to our Excel sheet, so what are the allowable capacity? Actually 164. That means our load coming on our column is okay. Now I will again go there. For every pile, our load is less than the allowable or less than its capacity of its capacity. Okay, so I'll close it. Now I'll go for punching shear. Now if our punching shear is okay, then we are okay. I'll go here, design, sorry, display, show punching shear design, and everywhere is okay except, okay, we're seeing that everywhere our punching shear is okay. Okay, everywhere our punching shear is okay. We have no issue with our punching shear. What was the thickness? Property slab section, yes, 35. In 35 inch our punching shear is okay. I'll close it. Now as our punching shear is okay, now I'll go for our actually for your case, if you see that your punching shear is not okay or they have some issue with your punching shear value, and this value should be it's better if you are able to control this value from 0.7 to 0.9. so here we are in 0.7, and again if we go for further treatment or further in modification, if I go ahead slab section, double click. If I go for, let's say 30, okay, 30, double click here, let's say again 30, okay, then okay, then click. Okay, 7.78. See, now it's failing here. 1.1 on 1.168. Okay, it's failing here. So I will actually I will use 35-inch thickness. I will close it. Okay, then again I'll go here, section properties, section, double click here. I will use 35 because our another pile cap was 42-inch. 35. Okay, then click OK, go analysis and check is it okay or not. Again come here, display, punching shear value. Now it's less than actually it's less than 1 or 0.9. It's better to maintain it 0.7 to 0.9, and you can as we are using 35-inch, then you can go for 34-inch, 33-inch, 32-inch. In this way you can maintain your final thickness. Now we are completely ready for our design. Okay, so in our next lecture we'll go for complete design and detailing, how we'll go for detailing of this pile cap. So thank you very much. Stay connected till next lecture.